Alright, we're on question 74. Determine if you can use the hypotenuse leg congruence theorem to prove triangle ACD is congruent to that one. If not, tell what else you need to know. So in this case, can you prove it? If you're going to use hypotenuse leg, you need to be able to prove the hypotenuses are congruent. Well, in this case, yes, because they share them, so that's going to be reflexive. And you need to be able to prove one of the legs of a right triangle. Well, this is obviously a right triangle because this side is right and it's parallel, which means that this one's going to be right. Same thing here, this is right to complement that, and it's parallel, so that means this one is right. So these hypotenuses are congruent, and this is a leg, and it's congruent, so yes, you could. If a pilot uses triangles to find the angle of elevation from angle A down here from the ground to her plane, how can she find measure of angle L? I'm sorry, to measure of angle A. This is 40 degrees. This one and this are going to be the same measurement because of vertical angles. You know that the angle here and this side length are congruent to, well, I guess you can't use that angle, so let me go back. This angle and this angle are congruent, so you've got one set of congruent angles. You got a side congruent to another side, and then you got another side congruent to another side. So it's side, angle, side. The angles are the included angles in between the two sides. So these two triangles are congruent to each other, and then because of CP, CTC, you could say this angle is congruent to that angle. So angle A is congruent to angle C, and so therefore it's going to be the same measurement. 2C for galaxies, this one and that one are represented by those points, A and B, and they are equidistant from Earth, represented by point C. So saying this one and this one are the same amount. What is a measure of angle A? So you gotta figure out this angle right here. Well, you know this is 115 degrees. You can figure out how much this one is, because the long straight line should be 180. 115, there's 5, 65 degrees, I believe. That's 65 degrees. This is congruent to that one because this is isosceles triangle, so that means this is also 65 degrees. That's the measure of angle A. Find the measure of angle Q down here, this isosceles triangle. That means this angle is going to be the same as that one, the ones directly across from the congruent sides. So you got another 2x plus 15. So to figure out how much x is, which is what you need to do first, you got a 2x plus 15, another 2x plus 15, and another x, and all of them together should equal 180. These are all angles. Angle plus angle plus angle can equal 180. Don't add up sides. But you do the math there, you got 3x's, sorry, that's 2, 4, 5x's, plus 30 will equal 180. That means 5x equals 150. That means x, when you divide by 5, will be 30. You're trying to figure out the measure in Q, which is right here, so plug in 30. 2 times 30, which is 60, plus 15, so I would say that's 75 degrees. Okay, pretty sure I did that right. Let's go to the next question. Trying to figure out the length of CA. CA, which is this side right here. Actually, you don't have to do this page, but you should know how to do this. This is equiangular, which means this one is congruent to that one, which means that one's congruent to that one. But in order to figure out S, we first got to figure out how long, or you got to put these two equal to each other. S plus 2 equals 2S minus, whoops, it's minus 10. Subtract S, I'm going to add 10, subtract S, those cancel out, these cancel out, so you get 12 equals S. You can figure out how much AC is when you put in 12, it's going to be 14, all of these are 14, if I did my math right. Okay, once again, I know you don't have that page, so you don't have to do that page, or that question. Because this was 14, page 14, we skipped page 15 and page 16. Now we're going to page 17. So page 17, tell whether transformation appears to be reflection. Yeah, looks like it does to me. Reflection should be, you could fold it up along that line and it would match up. Reflect a figure with vertices this and this across the x-axis. So if we're doing reflection across the x-axis, this is the picture, this is the x-axis. You draw all those 1, 2, which is right there, 3, 6, 2, 4, 5, 6. So 3, 6 is right there, and -1, 2, which is like right here. Okay, I messed up, so I started over. So 1 comma 2 right there. 3 comma 6, which would be right here. Negative 1 comma 2 and negative 2 comma negative 2, which is down here. Negative 2. Okay, it's a lot of points, but I'm going to say the picture probably looks something like this. You reflect them over the x-axis, so you just count how far away it is from the x-axis and go the other direction. So, for example, this one is 2 away from the x-axis. I'm going to go 2 down. Put it right there. This one is 6 away from the x-axis. I'll go 6 down. It'll be somewhere around like right here. This is 2 up. I'm going to go 2 down and put it right there. And this is 2 down this way, so I'm going to go 2 up. Put it right there. And then just connect all of the points. And there should be reflection. It's not a great drawing, but that should be reflection across the x-axis. Alright, so just do the opposite. Next question. Tell whether transformation appears to be a translation. Yeah, it's a slide, and they look the same. Let's go down. Tell whether transformation appears to be a translation. This is not a slide. This looks like a reflection to me. Find the translation of the triangle along the vector v. So you haven't had to do very many of these, but you can just count and see that this moves 1, 2, 3 across 3 squares diagonally. So we do the same thing. 1, 2, 3, and put the point. 1 squared, 2 squared, 3 squared, put the point. The same thing here. So it's kind of hard because it's in the middle, but 1, 2, 3, right there. Connect them. Okay? This is a symbol that you could use for translations. Translate the triangle with vertices these along the vector. So what this means is that you might also see it written like this. The x moves, sorry, that should be -1, and the y moves, I'm doing that wrong. Let me redo that part. You might also see it like this. Okay, this means that all the x values are going to change -1. So this would be a negative, this would be a 2. And then all the y values are going to change 3. They're going to get bigger by 3, so this is 7. This gets smaller by 1. It gets bigger by 3, so that's 2. This one gets smaller by 1, so that's 3. And this one gets bigger by 3. It's 5. All the x values will get smaller by 1. All the y values will get bigger by 3. And you can graph and see what happens. Basically, this is going to be a translation. For everything, this moves all the x values to the left 1, and this moves the figure, all the y values, up 3. So everything will move over to left 1 and up 3. Next picture. Next question. A dance performance, 4 dancers form a diamond at these vertices. Then they move along the dance floor following a translation vector. So translation vector, the x values are not moving at all, just the y values. So what will happen is that all these dancers are going to move up 4. And then they move along, say, coordinates after 6 such translations. So if they do it again, they're just going to move up 6 times 4, moving 4 up 6 times, so it'll be 24. Have 24 to each one of these y values. Tell whether transformation appears to be a rotation. I don't think so. If it rotated, then this should be down towards the bottom or something. That looks like a reflection to me. Rotate this triangle about the origin, so you could graph the points for -1, oops, this way, 1, 2, 3, 4, and -1, which would be like right here. 5, 3, so 5 and up 3 to be like right there, and so forth. Rotate it about the origin 90 degrees. When it doesn't say, that means it's going to be geez, now I can't remember if it's clockwise or counterclockwise. I think your book typically does counterclockwise, if I remember right. I'll have to double check that and tell you in class. But let's say you did it. Let's say you did it counterclockwise. I think that's the default if it doesn't say. So it goes 4 this way and down 1. So if we move this whole thing counterclockwise, then we'd be moving this way, and 4 this way, and over 1, and you figure out what the point is. It's 4 comma 1. I'm sorry, 1 comma -4. 4. Man, what's wrong with me? Same thing here. If you imagine this was rotated this line right here, rotate it that direction. So instead it's going to be up 5 this way and over 3 that way. Okay, put your point. I know the color's probably not the best, I apologize. But just imagine you rotate it, all going counterclockwise. The revolving restaurant on top of a hotel in San Francisco takes 45 minutes to complete a full rotation. A table is 30 feet from the center of the restaurant, rotates its position at, it starts its position at 30, 0. So 30 over and nothing, 0. What are the coordinates of the table after 9 minutes? Oh wow. It takes 45 minutes to rotate a complete circle, so 9 out of 45 would mean that it's 1/5 of a rotation. Wow. This one's going to make me have to think. Um, what are the coordinates of the table after 9? This question is way harder than what you need to be. I could eventually figure it out, and it's basically instead of rotating the whole thing, you're going to do 1/5 of a rotation. So you got to break this up into fifths and figure out where it's going to be. But that's way more complicated than you're going to see in your test, so don't worry about that. Let's go to the next one. As a triangle has these vertices and rotates 90 degrees about the origin and then reflects across the x-axis. So you rotate it 90 degrees counterclockwise. Since it doesn't say, we're going to assume that's the default to go counterclockwise. Once again, I need to check that with the book and see if it's not clockwise. But I think it's counterclockwise. So that means rotating this way 90 degrees. And then you're going to reflect across the x-axis. So then you'll flip it and see, put it over here. So wherever the point is, and you're going to flip it. I'm not going to do each one of those. You can figure that out as well. Anne wants to create a design to decorate her geometry binder. She reflects part of the design across the line P and then reflects the image across the line N. Describe a single transformation that moves the part of the design. So let's first scroll down just a bit. She reflects the part of the design across line P. So this is where she starts. She reflects it there and then reflects it across the x-axis, which they're calling line N. So what happens to go from here to here, basically? And it looks like it's just going to be a rotation. Okay, so if you flip and then flip again, it's the same as a rotation. I believe that's it. That probably doesn't answer all of your questions, but hopefully it answers most of them. Just please come prepared tomorrow. I'm sorry about getting these videos out so late, but you can watch them again over and over until you have your test. Good luck, and thanks for watching.